everybody. Welcome back to Statistics and Theory. In this video, I'm going to demonstrate how to do a multi-group structural equation modeling analysis. And the model that I'm going to fit in is this model that you see, but I'm going to walk you through the steps. Now, I should mention that I have created a few videos before this. My latest video before this video is about how to do a path analysis or structural equation modeling analysis using AMOS. So if you have not watched that, I highly recommend that you spend some time to watch that, because the current video builds upon the previous videos. In addition, I have created two videos on confirmatory factor analysis, which is a prerequisite to structural equation modeling. And one last thing before I start the analysis is that in this book, Quantitative Data Analysis for Language Assessment, the second volume, we have a chapter under section or part 2, chapter number 5, which is about structural equation modeling in language assessment. But if you are in other fields other than language assessment, I believe that the chapter would probably still be useful for you. Now, how to do this analysis? First of all, let's look at the data. The data that I've got includes several variables. The first group of variables measure confidence. Now, I should say that these three variables need reverse coding, but I haven't done the reverse coding. But that will be fine. The path coefficient will be negative instead of positive. Later, I will show that to you. The second group of variable is attitude, and it includes 4 variables. The third one includes strategies in language learning, and also includes 4 variables. And finally, we have language variables or language ability variables, which include grammar, vocabulary, comprehension, and 2 scores for writing ability. So I'm going to associate this data with the model that I showed you before. And finally, we have a gender variable. Gender includes 2 levels: males and females. Male, which has been represented by 0, and females represented by 1. Okay, and one last thing is, I think I also should explain this very briefly. We have used a Likert scale in these variables, and as you see, the Likert scale ranges from 1 to 5. Now I'm going back to this, and I want to show you how to do this analysis. First of all, we need to create groups. The 3 groups that I am going to use in this analysis is males, females, and also the entire sample regardless of gender. This is my model 1, but I'm going to create a new model just to show you how those steps are taken. Step 1 is under group number, we should create those 3 groups. So group 1 is going to be all. Okay, I'm going to double click and call it out, then call it all. That means the entire sample size. You can call it anything else if you like. Then click on new to create another group for your males or females. So let's start with males, and then click new again and create females. Now, if you have other groups, you can go ahead and create more groups there and close. The next step here is to associate this data set that I showed you, and I have saved on my desktop, with this analysis. So how do we do that? We can go from File and click on Data File, or we can simply just click on this button here, which is called Select Data File. So I'm going to click on it. As you see, I have those 3 groups represented here. You see there is consistency between this box and the box here. The first thing I would like to do is to associate the entire sample with all. So click on File Name, and I'm going to find my own data set, which is here. And I want to check, yeah, the sample size is 1896, so it's a large data set. Next is for males. I'm going to use the same data set actually, I'm going to click males and file name, and go to the desktop to associate it. Now the difference between this analysis, this association, and the previous one is that I need to have a variable here. So I'm going to let AMOS know that I want to use the grouping variable gender. So I click on this line here and I click grouping variable and I choose gender, click OK. And then in gender, I only want to have one of the groups here. So group value has to be chosen, and I'm going to choose 0 because 0 stands for males, and then click OK. Now I have associated the male data with the second group. Now the last analysis is going to be with females data. Click females, click file name, again choose the same file, or you could have chosen different files, it doesn't really matter. This is the file that I chose before, open. Now again grouping variables, again gender, okay, and finally group values, which is 1. As you see, I have also some missing values here, which doesn't matter. AMOS will ignore them. Click OK. So everything seems fine. All males and females, the data has been associated with males and females. Since there is a good link between them, I'm going to click OK. So the data is now ready and I can start to draw the path analysis that I want to do. So as I explained in the previous video, you need to draw a latent variable and then add indicators or observable variables. So let's click on this, and on the main interface, click once and keep clicking 3 times or 4 times. The number of clicks equals the number of your indicators. Here I've got 3 indicators, so 1, 2, 3. Okay, that's one of the latent traits that I want to use in the analysis, one of the latent factors, that's better terminology, and the indicators. Now I can go ahead and do the same thing for the second and third factors, but I think an easier way would be to click on this hand icon, and that's select all objects, and then click on this copy or duplicate icon and drag and leave the shape here, right, somewhere, on the interface. You can do the same thing for the third and for the fourth variables that you have, and then unclick or deselect all objects. Now we can turn these around, for example, by clicking on rotate, and this one rotate, this one rotate. Okay, so as you see, I have already created 3 variables. Four latent factors. In addition to that, I have created their indicators, and these little circles that you see represent errors that are associated with observed variables. Now these can be extended, for example, for the groups of variables, attitudes, where I've got 4 attitude variables. I can add on one more variable, but again, clicking on draw latent variable. Here, let's say I'm gonna make this small confirmatory factor analysis. Each of them can be also referred to as a confirmatory factor analysis. I'm gonna associate this with attitude. So click once and I get 4 items, and the other one is strategy. I'm going to associate this with strategy. Okay, so I got 4 items for the 4 strategy items, and last but not least is that I've got 5 variables for my language latent factor. So I can click once and twice, therefore I've got items. Now the next step is click on this icon here in order to get the list of your variables, and really just drag and drop. So I'm going to drag confidence 1 into the first indicator, and then the second one into the second indicator, and the third one. And so since I've got confidence items here, I'm going to double click on this oval shape and go to the text tab and call this confidence. Okay, and in the same way you can click on this oval shape here, the latent factor, and call it attitude, and so on and so forth. And then in the same way you can drag and drop the variables into the indicators. And if you want to move these oval shapes and the associated indicators around, I would suggest that you first click on this preserve symmetries button, and then the truck icon, which moves objects around, and then you can move the entire confirmatory factor analysis around. This is the second one, this is the third one, this is the fourth one. Okay. All right. One last thing before I go back to the model that I've already created is you can also name these errors by going to the plugins and by clicking on name unobservable variables. In this case, of course, the two latent variables which have not been named will also be automatically named in this way. See F1 and F2, but you can double click and change these. For example, this one can be changed into language, and the second one could be changed into I think it was a strategy, yeah, strategy, and that should be just good enough. Now in order to okay, let me just really drag and drop these variables for you so you will see how it's done quickly. Strategy goes here, strategy 2 goes there, or it doesn't matter, strategy 3, 2, and strategy 4. And for language, we've got grammar, with vocabulary, comprehension, writing score 1 and writing score 2. As you see, they are sticking out of the variables, the boxes. So double click and remove the variable labels so they will fit again. In the same way, just click on the variables and remove the variable label and close it. Now this analysis is almost ready. What I would need to do now is to draw the path between these latent factors. So one path moves from confidence to language, because my theory says that confidence can predict language, attitude to language, strategy to language. In addition, my theoretical framework allows me to create correlations or covariances between confidence and attitudes and strategy. So I click on this double-headed arrow and create those covariances. And between all of these. Okay, since I have 3 exogenous variables, and exogenous variables are those variables that affect or exert an influence on another variable, which are similar to independent variables. So I have 3 exogenous variables and 1 endogenous variable, which is similar to dependent variables. I need to draw a unique variable associated with language, which is my endogenous variables, and that's the unique variable is actually an error of measurement, which is you can just click this, so move it around like that. It's an error of measurement which is associated with endogenous variables. As you see, every variable that receives an impact from other variables has to have this error of measurement variable attached to it. For example, these indicators or variables receive an impact from confidence. As a result, they need to have these E's or errors. So I can call this automatically by clicking on name unobserved variables. Yeah, so the label has been chosen. Now, of course, this model should fit into this white box right at the back. Since it doesn't fit into it, I'd like to just go back to my own model, which I had created before. It's actually the same thing, but I think aesthetically it's more appealing. So I'm going to click no because I don't want to save this really. I just wanted to show how it works. So again, I've got the latent variable or latent factor confidence, the latent variable attitude and strategy and language. And I am measuring the effect of attitude, strategy and confidence on language, and they have got covariances. Right. One more thing is that if you notice there is a little 1 beside one of these arrows per latent variable. This is to fix the estimation of that variable. It's important, it's necessary in structural equation modeling to fix, or to, as I say, to free that variable from estimation. I think everything is ready. Now we can click on analysis properties. I would like to go to estimation because, as you remember, we have some missing data, therefore we have to click on estimate means and intercepts. I'm going to use maximum likelihood measure way of estimation or method of estimation because my data, I assume, is normally distributed. In other videos I have discussed how to check normality. Now I would like to get standardized estimates and squared multiple correlations, as well as direct and indirect total effects. So the data is now ready and the model is ready for estimation. I would like to click on calculate estimates, and the estimation is done now. Okay, a few things. First of all, you can toggle between these groups. For example, let me just zoom in a little bit here and click on standardized estimates. For example, for confidence, you see the standardized estimate or the path coefficient between confidence and confidence 1, conf1, is 0.77 for all. For males, now I'm going to click on males, is 0.78, and for females is 0.75. So the changes are not that respectable. Of course, this is one way of looking at those estimates. I suggest that you go to View Text tab here, click on it, so that you can get the estimates for all items and all the paths that we have included in the model. We have three tabs here. All. So once you click on all, the estimates for all variables, all the data will be presented. If you click on males, then it will be changed to males and then females. So let's compare males and females first. If you look at the the effect of confidence, attitude, and strategy on language for males, you'll see that the first two are significantly affecting language because the p-value is smaller than 0.05, but the third one, strategy, is not does not have an impact on language, and that's actually quite interesting. The other one is for females, and for females things change quite significantly because every variable has a significant, and I assume a high impact on language. Now you can scroll down further to see the impact of these variables on language. These are standardized regression weights, or standardized beta coefficients, or standardized path coefficients. It goes by different names, and it's analogous to the effect size, which you would calculate in multivariate analysis. So the effect size of strategy and the effect size of strategy on language is 0.472, and if you click on this number, this statistic, you will see a very brief explanation popping up. It says when strategy goes up by 1 standard deviation, language goes up by 0.472 standard deviations. That's pretty high actually. But to be more specific, I would say anything between 0.3 and 0.5 or so is about, I mean, depending on what textbook you will refer to, some people say it's medium, some people say it's low. To me, it's kind of a medium size effect. This one is low but still significant, and this one is about medium. what I would like to stress here is, as I mentioned before, confidence and the variables in confidence need to be reverse coded. Otherwise, you will get a negative direction, which might surprise you if you do not remember why it has happened. So the reason why we've got this negative sign here is that the variables needed to be reverse coded. I didn't do that before doing the analysis. And then you can go down and find out, for example, the correlation between the latent variables, between strategy and attitude, etc. for females and for males. You see the correlation coefficients change, and finally for all they change somehow. So you can provide them in a very nice table in your paper if you are interested to present these in tables. And then you can go down to standardized indirect effects or standardized direct effects, or is that standardized direct effects, to further look into the effects. So standardized direct effects are just pretty much like what I showed before earlier, like these effects. And finally, we should also check whether every item significantly measures the latent variable or the latent factor. As you see from these p-values, every item significantly measures them, but we also need to look at the standardized regression weights. These standardized regression weights are fine to me, but I also need to check the last thing, which is model fit. The model fit is estimated for the entire groups, not just one group. And the model fit here, I'm afraid is not very promising, because I would like to see something at least greater than 0.9 for CFI, or comparative fit index, and TLI, Tucker-Lewis index, also goes by NNFI. But it's still small. One of the strategies that you could use is to go to your model and look at these variables, these statistics. So let's look at them and see which one of them is small and which one you want to remove. I think for language, this is 0.5. It would have not be an issue if our model had a good fit, but we don't have a good fit. So I would recommend that we toggle back to here, the view of input and path diagram, and perhaps remove this variable just temporarily to see what happens to the fit. So I'm going to remove this and perhaps move this up a little bit just for some kind of cosmetic change to the model. And okay, one more thing is, before running the analysis, I have to double click on one of these paths and fix one of the parameters to 1, as I mentioned before, the regression weight to 1, and close it. Now the analysis can be run again. Let's do this. All right, this is taking some time. So the analysis is done, and I would like to go back to the fit statistics. Fit of the model is much better, as you see, but I'm afraid this normed chi-squared value, which I discussed in other videos, should be below 3, which is not the case here. And you have probably seen this statistic here, which is 0.47, which is quite disappointing in this model. The other thing I could do is to drop this. So let's see what happens if I drop it. Again, click on the option and remove. And I need to fix one of these these paths again to 1 and estimate. So we can see how this estimation works this time around. Okay, so go to model fit. So I don't see a big change in the norm chi-squared value, but the TLI and CFI look fine to me. So one of the reasons why this model is not very optimal is the fact that I have not used all the variables that are measuring confidence, attitude, and strategy. I suspect that if I had included all of those variables, which are not in this file, by the way, I would have gotten a better fit. I think I would do that probably in another video in the future. So one last thing before I close this video is that you might be asking me, why do we get only model fit for one of these groups? Why not for all of the groups? In order to do that, you can actually fit the groups one at a time, meaning one analysis for males and then separate males from females and then separate them from all, but that's going to take quite some time. So this is actually easier, but as you see, you will get only one fit statistics for the three groups. So this brings me to the end of this video. I hope you find it useful. If you found it useful, please give it a like and subscribe to this channel, and have a great day. Thank you.